Lemon squeezy. Now, let us remind ourselves about fractions. Is that fraction in its simplest form?
Yes.
Excellent. So, you would not simplify that anymore. You should probably go get that book, Bryce, since that is worth 30% of your grade. How can I write another fraction that has different numbers here and here, but is worth the same value? What can I do to that fraction?
Multiply it by 2.
I could multiply it by the same numerator and denominator, yes? Now you are all intelligent people. Yes. If I multiply this by, somebody say a number between 1 and 10. No, I lie, because some clown is going to say 1. Say a number between 2 and 10.
9.
7. If I multiply by 7 over 7, isn't that 1?
Yes.
Yes, and multiplying by 1 doesn't change the value, does it? No, it just changes what it looks like. And this would become 14 over 21. And you all know that already. Yes?
Yes, sir.
So, if I have any fraction, x over y, and I multiply it by some other number, and we remember that that number has a value of 1, then I get the same value fraction. X over y will equal xn over yn. Now I know that the letters in math mess you up, but I can't write all the numbers, can I? Because remember, a letter in math by itself is just a number. Is everybody good? Now, being the intelligent young people that you are, if you multiply by 1 and it keeps the same value, what can you do if you need the numbers to appear smaller?
Divide.
I would divide. So I could divide by the same value. Somebody give me a number that works here. 3 over 3. Is 3 over 3 1? Is dividing by 1 keeping the same value? So I get 9 divided by 3, which is 3, and 12 divided by 3, which is 4.
Can't see it.
It'll catch up. It's just frozen for a second. Actually, it'll probably go black in a second. Put a big pause sign on the screen, and then we'll see what happens. Oh, it went blue.
Here's a pencil.
Now we will try to reconnect, and it won't work. But unlike many other teachers in the building, I understand technology, and I will fix the problem. Because that's what I do. I fix problems. Right, Manning?
Yeah.
You know it, brother. Plug.
You look like you're very tired.
I am very tired. Did you not hear what I did all weekend? It was a busy weekend.
Lots of sports.
Yes, lots of sports. And do I have a body that is prepped for lots of sports? No, I do not, because it is old and it has been abused.
No offense.
All right. So, we are here now. So, I am going to write a fraction in black right over in this empty space. Everybody cool?
Yes, sir.
I'm going to write 6/8. I want you to give me 2 fractions that equal 6/8. I want one of them to be in the simplest form possible, and I want the other one to just be another fraction that equals 6/8.
Equals 2?
Yep, 3/4. That is the simplest one. Why? Because I divided both sides by 2. What is something that I could put over on the right?
Multiplying.
Multiplying by what?
2.
2, which would get me
12 over 16.
12/16. That is times 2. Now, which of those is the one we are more likely going to do in this class? Are we going to do the yellow or the green?
Yellow.
We are more likely going to do the yellow because that is the simplest form of the fraction. Now remember, when your grade 5 teacher called that reducing a fraction, that is technically wrong because they are the exact same value. And when you reduce something, you make it smaller. Does everybody understand that? Now, you in your own head might say, I have to reduce that fraction. That's fine. I won't say that. I will say simplify. Do we all understand?
Yes.
Excellent. All right. If you all understand, there are 6 fractions there that need to be simplified. Go. And as always, it's good to get the early ones out of the way because they're the easy ones. Marcus, your hand went up first. What is it?
1 over 3.
No.
4, 8, 12. 1 over 4.
1/4 because you divided both by 4. Jer, you would like to do the second one? What is that one? Also 1/4. Unbelievable. Now we get to some more difficult ones. Anybody want to do C? Hit me, Aveline. 1/3 because you divided them both by 25. Now let's say you didn't divide by 25. You used 5 because they both ended in 5, yes?
Yeah.
Which would have gotten you 5 over 15. Do they still both end in 5?
Yeah.
So you would divide by 5 again and get 1/3. You might need to take more than one step to simplify a fraction. Is that okay?
Yeah.
Excellent. Miroslav, are you doing D? What is it, my friend? 5/7 because you divided them both by 3. Who is doing E? Marcus, some redemption.
4 over 9.
4/9 because you divided them both by 2. And who is doing F? A new hand would be nice. Nobody? No, you have the same hand. You've had 3 cracks at it. Oliver, hit me. 9/20. Does everybody is everybody able to simplify fractions?
Yeah.
Spectacular. Have we already done it this year? Yes, we have. Are we going to need to do it for this whole unit? Yes, we are. Let us move on. Cabbages. Wait a minute. Where's page 6?
I have page 6 right here.
But I don't. How embarrassing. Yeah, whatever. Go.
Oh, just get a number.
Well, this is just... Boy, is my face red. How embarrassing is this? Give me a moment. You all take a break. Talk amongst yourselves while I bring page 6 into my book here. Oh, I'm so... Have you already seen that construction this year numerous times?
Yeah.
Yes, of course you have. You all know how to do it. That is what we call proportional reasoning. We are comparing 2 different ratios. I gave you a fun little rhyme. Multiply a pair, and that pair is, of course, diagonal. And then divide the spare. So, when you look at this question, do you see a diagonal pair? Yes. Of course you do. And what do you get? It is 16 and 5. Do you see a spare? A number that isn't part of the diagonal pair? Yes, 24. So with your calculators, because they are your best friend in this room, you will punch in 16 times 5. That's multiplying the pair, dividing by the spare, and then equals. And you will get what I despise, a decimal. And what is that decimal? 3.33 forever, which we round off to 3.3. And that number equals x, which goes in that spot. Is that complicated to any of us?
Nope.
No. So that first one is circled because I'm going to do that one. You are going to do the rest. There is your pair. 40 times 10. There is your spare divided by 50, which will get you an answer of 8. Because you punched it into your calculator. You will now do those 8, 7 left over. Oh, wait, I feel I should do F. That's why I circled it, duh. Because the pair is this way. It's the same pair, but the number, the spare, is now on the numerator. Does it change how we do our math when it looks different? No. So this one will, of course, be 12 times 15 divided by 3, which will get you an answer of 60. Won't it? Yes, 60. Now you do the other 2, 4, 6. Remembering that no math will change. Also remembering, if you still do not have a calculator and you are still insisting on using your phone, all that is well and good until a test, when I will not let you do that. So please get to the store and get yourself a $10 calculator, because that's more than enough for this course. And I will wait whilst you do those 6 ones. Written out the work, but you did not see me punching into calculator. Some of those numbers are big. It is Monday morning. I'm not going to bother doing the math in my head because you are going to supply me with the answers because you all have your calculators. So, what is the answer to B? As in, boy, is this math easy because I'm using my calculator to do all of it. Jer? 24. By a show of applause, is Jer right? Show of applause, Manning. Show of applause. What is C?
7. Oh, 7.
7? By a show of applause, is my good friend Marcus right? Less applause for you, Marcus. Hurtful. Hurtful. Because you're right. What about D? 54. Marcus is on fire. I didn't say show of applause this time. By a show of ducks quacking, is Marcus correct? Why not? That's no fun. Everybody likes making duck noises. Okay. What is E? 1,542. With a show of chickens clucking. Is Marcus right? Nothing? Okay. Boy, Marcus, I'm trying for you here. Nobody wants to have any fun in math class. I was like, math is so lame. I hate it so much.
Monday morning.
Okay, fine. You guys don't want to have fun? We can do math the boring way. What is the answer to G?
16.
Aveline, 16. Aveline is correct. No, 60, not 16. 60.
60?
No.
Wait, are we on?
We're on G.
Oh,
I did F already. Oh yeah, y'all get credit for F, the one I wrote down.
I did it.
What's G? 276?
Yeah, I know.
Okay. And what is H? 125. So can everybody do multiply the pair, divide the spare? Of course you can. You are going to do that about 1,000 times this week. No, not true. 1,000 times this year. It is, when in doubt, it is what math you are going to do. If you are concerned about how to do the math on the page in front of you, it is probably this. Everybody cool? Okay. Let us turn the page over, cabbages. Huh? It's on the same page for you? No, it's on page 7.
We don't have to turn.
Great, don't turn the book, man. Just be writing on page 7, brother. You do you. All right, so we all remember, what does a ratio compare?
One thing to another.
Yes! A ratio compares two different values. Well done, Marcus. Right? So, a ratio compares two different values. We often write it like a fraction, don't we? And that's okay, because doesn't a fraction compare part, which is one value, to the whole, which is a second value? Do we all agree? That's why they work together. They're not quite the same, right? Because remember, if we were to do super handsome old men compared to super handsome and good-looking young people in this room, it would be 1 to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. It would be 1 to 22, wouldn't it? Right?
22 boys and stuff.
But if I were to compare super handsome old men to all the people in this room, it would be 1 to 23, wouldn't it? Does everybody understand that difference? Yeah? Okay. And what does a proportion compare? Do we remember? It compares two things. Okay. This whole section is called proportional reasoning. You just compared two ratios using the proportional reasoning. So what must a proportion compare?
Two proportions.
No, two ratios. Two ratios that are equal. So x over y will equal a over b. And you usually need to find one of these. That one, that one, that one, or that one. And how will you find it? By multiplying the pair and dividing the spare. Now, can anybody remind me of the ways in which I can write a ratio? A couple of them have been, one of them is written on this page.
Fraction.
You can write it as x over y. Can anybody remember another way you can write it? With a colon, x2y. Can anybody remember a third way? Well, a slash is the same as a fraction. You can write it in words, x2y. Now remember, order matters. So go back to my previous example. Super handsome old people, super good looking young people. Which number goes first? The oldsters or the youngsters? Oldsters. So it would be 1 compared to 22. So the 1 would go in the numerator spot. Does everybody understand? If I change the order, super good-looking youngsters compared to super good-looking oldsters, then what would that ratio be?
Youngsters first.
So it would be 22 compared to 1. Does everybody understand that?
Yes.
Excellent. So When you're working with ratios, you often want to simplify them first. Now, I told you in the intro unit that we don't simplify ratios, do we? Like if you just wanted to say in this building how many people are left-handed, you might write 400 to 1,007, right? However many kids are here. That might simplify. But if you're just saying the ratio, you don't want to simplify it. But when you're working with ratios, you do want to simplify them. Does everybody follow me? The ratio itself stays true. But when you're going to do some math with it, you want to do math with smaller numbers, don't you? So you would simplify. So if I gave you this ratio, 565 compared to 1,150. So what does that say? That says 565 somethings out of a total of 1,050, right?
Yeah.
If you were going to work with that, do more math with it, then you would want to simplify it. Have we today reminded ourselves how to simplify these? Sure we have. What would we do when a number ends in 5 and ends in 0?
Divided by 5.
I would divide by 5. Can you do that in your head?
No.
Probably not. So where will you go?
Calculator.
To your calculator. And what will you get?
Um, 113 over 230.
113 out of 230. And we are all good. Yes?
Should be.
Now, in real life, we often use proportions when we're dealing with ratios. So let me give you an example. I am going to write a ratio in words. Canadian dollars compared to US dollars. I don't need the dollar sign. Canadian dollars compared to US dollars. Which number will go first?
Canadian.
Canadian, because that is first. Now, I don't know the exact comparison right now, and I'm not going to look it up, but it's about 71 cents. So 71 cents in US is $1 in Canadian. Okay? So I would write 1 compares to 0.72 in US dollars. Mr. Myers, that's a decimal. I know. Does it look different?
No.
Doesn't this look different than every other ratio
yeah.
we've done?
Yep.
Okay, so it looks different. Are we going to do the same math?
Yeah.
When something looks different, we still do the same math. So how do I write that in such a way as to be able to do math with it? Right. So I had Canadian compared to US. Canadian to US, which was 1 over 0.72. Now I'm about to go to Sumas for dinner tonight because I love me some El Nopal. I know there's better Mexican food available in Abbotsford right now, but I loves me some El Nopal. So I'm going to go to El Nopal for dinner tonight. I'm going to have to pay for everybody's dinner because I'm the grown-up. So I want to know how much that's going to cost me. How much should I bring? I'm going to bring $150. So am I bringing Canadian or American money to this party? Canadian, because I'm in Canada.
Yeah.
Where does the 150 go if I'm making a proportion? Up top, because order matters. Canadian was first. Canadian was first. How much American money do I have? I don't know. So what do? I multiply the pair and I divide the spare. But the spare is 1 here, isn't it? So do I even really need to divide by it? All I got to do is the multiplication. And how much money will I have when I go to El Nopal?
108.
Exactly?
Yeah, it says.
It wasn't supposed to be. It was supposed to be some sense. It's really 108 exactly.
I did the 0.72.
Damn it! No. What? Let me see that again.
150 times.
Shh. You did plus.
I did?
I thought I see a plus there. Let me see.
That's multiplication.
Oh, it is times. Damn it! Well, let's pretend there was some cents there. We'd round off to cents, wouldn't we?
Yeah.
So, does everybody see how it works? It's the same thing we've been doing all the way on. Multiply the pair, divide the spare,
Are
yes?
you actually going there tonight for dinner?
Yes, I am. That's a true story. I'm going to go to El Nopal tonight. I'm going to get the flautas.
Do you eat it spicy?
Yes.
How spicy?
Very.
It's good. Not like boy spicy?
No.
Good.
All right. Now, you are intelligent young people. You invited 5 friends to your house and you're going to make them brownies. I loves me some brownies, but I like a fudgy brownie, not a cakey brownie. Cakey brownies can piss off. Fudgy brownies are where it's at. So, the recipe I found makes 20 brownies, but I only need 12, 2 per person. Now, this is the type of question that you need to be able to do. All right? And you're going to use the math that you already know. So, when you read this question, you see that you have a great recipe that makes 20 brownies. Do you all agree?
Yeah.
So, how many recipes do you, what's the first thing you read? Recipe or brownie?
Oh, brownie. It says, right? Oh, wait. Recipe.
Does word order matter?
Yes.
So the first thing we read was recipe, yes? So recipe, is it in the numerator or the denominator? Numerator. And it compares to brownies, yes?
Yes, sir.
How many recipes do you have? No,
12.
dude. Oh. What does that say?
You found
No. Right here. What does that say? A great recipe.
I can't read that.
I have a pen. How many pens do I have?
1.
1. So I'll ask again. How many recipes do I have?
1.
1. How many brownies will it make?
20.
20. Do I want 20 brownies?
No.
No. How many brownies do I want?
12.
2 per person, Manning. It says in the question. I need 12 brownies. Where does the 12 go? Blue or green? Look at the fractions, kids.
Oh, it goes green.
It goes on the green. 12. What is the unknown is right there. How do I find the unknown?
Multiple.
Right. What do I get when I do 12 times 1 divided by 20? I get 0.6. So what does that mean? Everything in the recipe has to multiply by 0.6. That's how you do it. So if I needed 1 cup of flour, what would I do to 1 cup of flour in the original recipe? I would have to multiply it by 0.6. That's how we use proportions and ratios in real life. Is everybody good? Please notice, all the information was in the question, wasn't it? Recipe read first, right there. Recipe compares to 20 brownies, right there. I only need 12 brownies, so I'm comparing recipes to brownies. I don't know how big the recipe will be to make it down to 12. Yes? All right. Very well done. Now, one thing that is very sexy in math class right now in this world is to make you think of math not using numbers, using pictures. So, right there you see a triangle, yes?
Yeah.
So, if now the first thing I say to do is copy the triangle onto graph paper. I've already done that for you. It's right there. All right? Now I want you to take that triangle that you have right there and do these 4 things on these 4 graphs. Does everybody understand? Now I'm going to remind you of how this is to be read. Remember, AB is the line from A to B. All right? So the very first thing I want you to do is double AB, which is in pink, and AC, which is in blue, and I want you to draw that on this graph. Does everybody follow me? I would start in the bottom corner to make sure I had enough room. Go. Then do all 4 of them. But it's all written there.
It's 13.
Point. Give me 1 decimal.
0, 1. Oh, 0. Just 13 then.
Okay, so 13. Does everybody agree? So she's going 13 meters a second.
That's a lot.
That's very fast.
Oh my God.
You want to know how fast she's going in kilometers? Multiply that by 3.6.
13 times 3.6.
Yep.
46 kilometers. Oh,
She can skate at 46 kilometers an hour.
47. What the heck?
47.
Well, that's fast.
That is fast.
That's pretty fast.
That's why she was a gold medalist. And that's why her thighs are as big as my waist.
Actually?
Oh, she's huge.
I can't tell if this is a compliment.
Of course it's a compliment. Thighs that muscled? Awesome.
You know.
Okay, so you are all intelligent young people. It doesn't matter what we're counting. We're doing the same math, aren't we?
Yes.
So, what is the first thing you read there?
The money cost.
So you see money over grams. Do we all agree?
Yes.
Okay. How much money do we know? 1.89 will get us how many grams?
100.
100 grams. Do I want 100 grams?
No.
What do I want?
250.
So where does the 250 go?
Below.
Yellow or blue?
Blue.
250. Do we know how to solve that?
Yes.
In our sleep. What's the answer?
4.2.
4.2?
4.7. 4.72. Right?
I don't know. I don't have a calculator.
Yeah, it is.
Really? What's the third decimal?
5.
So what happens to the 2?
Round up. Oh, 4.2. 72.
Does everybody see how this works? It doesn't matter what we're counting. We do the same math. Doesn't matter what the question says. We do the same math. Okay? A Gonectigazoink costs 1.89 thingamajigs for 100 who's-a-whatsits. Does it matter? No. So, you prove it. Read this question. Do you see a formula you can write, or a ratio, a rate, because we're comparing 2 different things. Do you see a rate you can write there? We're doing 2 more questions and the day is over and you don't have any homework. What do you see a rate you can write there?
100 copper plated.
So you see pipes first compared to what?
Money.
Money. So what are the pipes? Pipe straps. 100 compared to what?
100 compared to 4.97.
How many pipe straps do I need?
75.
So where does that go? Yellow or green?
Yellow.
Yellow. 75. Do you know how to solve that? Of course you do. How do you show me you understand the math? You remember that money rounds to how many decimal places? 2. So I better get this answer correctly. Remember, that is 75 times 4.97 divided by 100. What is it?
3.73.
Easy peasy lemon squeezy.
Yes, sir.
Except this time we're counting pipes and money. Does the math change? No matter what the paragraph says, I do the same math, don't I? So, you do the last one. What is the first things being counted? What's the first thing you see?
Money and time.
Money over what?
Time.
Time. Do you know how much money you're making?
Yeah.
What is it?
150.
150. Over, do you know the time you're working? What is it? 12. You want to know 40. Where does the 40 go? Blue or yellow?
Yellow.
Why yellow?
Because it's time.
Because it's time, and time is on the bottom, and order matters. What goes in for the blue?
500.
Well, first you're going to do an X, and what's your math going to be? 150 times 40 divided by 12, and you get, Marcus?
500.
$500. Can any of you really look me in the eye and tell me the math is difficult?
No way.
Do you get a calculator for all of it?
Yeah.
Yep. All right. That is it for the day. You have no homework. Tomorrow we will be working in this book. You will be expected to apply this knowledge to work. Is everybody cool? Okay. It's almost like I timed it.